So on Tuesday, we're heading to central Connecticut. So Connecticut's a kind of small, dinky, northeastern state, but it actually has a fair amount of interesting geology, and New York State as well. So actually, I plan to head to the Yale Peabody Museum tomorrow. It's free museum ticket day from the Smithsonian, so if you want to, I'll email around. You can get free tickets to hundreds of different museums. But Yale Peabody Museum has an exhibit going on right now that's talking about the history of the museum itself and the role it played in the development of American science in the early days. And in terms of American geology, a lot of the early work was done around this area. Obviously, a lot of that is because that's where European colonization was, but there is a lot of interesting geology around here. The central Connecticut area, New Haven, Meriden, and so forth. So Yale, itself is kind of in the middle of a kind of interesting geological settings, and that really kind of played a role in early exploration of American geology. Specifically, we're going to be trying to get a handle on the Rift Valley that is running down the center of Connecticut. So I'm not going to give a whole long history of this area. We'll kind of breeze through the first 3 billion years. Many of you are probably familiar with Pangaea, but about 1 billion plus years ago, there was another lineup of continents into a supercontinent called Rodinia. Oops, let's get a pencil up. At the time, what would eventually become the core of the North American continental plate was sort of, from our perspective, lying on its side down at the equator. Okay. So Connecticut, or proto-Connecticut, what would eventually become Connecticut, was actually in the just below the equator in what would have been at the time, tropical kind of environment. And so, I guess just the points I want to make up here, as these masses are coming together, obviously we're getting a lot of convergent plate boundaries, a lot of tectonic collisions. That clearly is going to be forcing up a corresponding mountain chain. What we have going on at this time is known as the Granville orogeny. Orogeny is just mountain building episode. So we have a huge band of what is left of the Granville mountain chain running along the eastern edge of the North American plate. Okay. So this would have been a mountain range that would have rivaled clearly the Rockies and even the Himalayan mountains, although the Himalayas are pretty extreme. And then what we have left of that is essentially the roots of those mountains, because most of the mountains got worn away a long time ago. But a lot of the gneiss and schist, the deeply metamorphized rock that you find in northwestern Connecticut. So, for example, the bedrock that's sticking out on my property, northwest Connecticut, is essentially 1 billion year old gneiss that used to be at the bottom of this several mile high mountain chain, exposed to lots of pressure, high temperatures, and then all of those mountains got eroded away. Continents tore apart, came back together a couple of times, but this is just kind of laying the precursor for our story. As part of this, we had, first of all, the Grenville orogeny, and then there was the tectonic orogeny later, which gave rise to the tectonic highlands. We have these shallow oceans being closed up by continental drift and then being pulled back apart again, oftentimes involving these volcanic islands, arcs that are off the coast. And a good question would be, why do we see all of this volcanic activity at the edge of this plate? We'll come back to that when we're talking about volcanoes. Of more interest to our story for Tuesday is the fact that we did have Pangaea. So about 500 million years ago, Rodinia had fallen apart. There was this Iapetus Ocean between Proto-North America and some of these other land masses like Baltica and Siberia, Abylonia, England, and so forth. And then that Iapetus Ocean got squeezed out of existence as the plates came back together. And so about 250 million years ago, during the Mesozoic, we've got the continents together as Pangaea. Okay. So late Triassic to early Jurassic, so a part of the way through the Mesozoic, we get things starting to be ripped apart again. In particular, the northern continents rip away from the southern continents, and so we have a whole lot of rifting that's going on in here. We have the intrusion of a shallow sea. We've got pieces of the crust that are being pulled apart, and that's in particular what's going to leave its mark on the landscape that we're going to be looking at on Tuesday. So as part of this rifting process, pulling apart process, we get all of these areas of rifts forming, including this Hartford Basin and the Newark Basin. It's part of this larger Newark Rift system. And that has basically left this kind of impact on the landscape. What we see as we look across this region are the remnants of the old gneiss and schist from the Granville and tectonic uplifts or orogenies, and as the areas get pulled apart, we get a variety of faults developing that we'll talk about fault processes later when we actually get back to talking in more detail about tectonic activities. But we have a variety of sediments and volcanic layers that are laid down during the Mesozoic in this area. And then the continued faulting and rifting apart basically has caused these layers to drop down at an angle across the landscape, and then subsequent erosion has kind of planed off the surface. So this is essentially, this part is the Central Valley of Connecticut. And so you can see we've got a fairly complex geology going on in the center of this little state. You can see this from space. So Connecticut is going to be kind of in here. And we've got the Western Highlands, the Eastern Highlands, got the Connecticut River and other rivers flowing down through here, and then we have this Central Valley, which is basically the result of this rifting process. So over here further, Africa as a whole got ripped away from, Proto-Africa got ripped away from Proto-North America, leaving behind some little bits that we'll talk about later. And as that process was going on, it essentially was tearing apart this region coming up through the state as well. But not enough. I mean, eventually it gave way over here so that it did not fully pull this part away. So if we look at New England in general, we have these parts that are clearly from the original Proto-North American plate, the Granville Formation, tectonic, and all of those other things that really were always part of the Proto-North American plate. We have a little bit of terrain called Avalonia terrain that at one point was joined with the plate that is now hosting Africa, but got left behind as that major rifting process took place. All of this landform that's labeled Iapetus is a whole variety of different terrains that were produced by that pulling apart, creating a shallow ocean, creating volcanic arcs, pushing it back together, pulling it apart, and so forth. So it's fairly complicated in here. And then this Newark formation in the middle is essentially this igneous landform process that was created as part of the rifting. Well, this just shows that there are actually a variety of fault systems in Connecticut that correspond to this rifting, but what I want to show is this next slide. So this is a generalized bedrock map of Connecticut, and so you want to be comfortable looking at these kinds of materials. Basically, what is shown here is if you scraped off the topsoil from the state and look to see what kind of rocks we are exposed and where they date, when they date from, you would have the bedrock map of the state. And if you look down here, you've got different groups of strata. So for example, the bright red and the kind of lemon yellow here are two different landforms that are associated with that Newark rifting. It's the Hartford Basin, basically. So the red here are basically basaltic outcrops that are running down through the Central Valley. And then we have some Mesozoic age sedimentary rocks that are around those outflows of basalt. The Iapetus terrains will date to an older period, and then we've got Proto-North American continental terrain as well. So, I mean, we're up here, somewhere up in here, where I've got billion-year-old gneiss coming out of the ground as bedrock in where I live, and Purchase is going to be down here somewhere. Also, Purchase is also kind of in the in some younger actually some younger gneiss and schist formations. So the idea on Tuesday would be to get out into the landscape and examine some of these different landforms that relate to the igneous and to some extent sedimentary processes that are going on in the Mesozoic in this area of central Connecticut. Okay. So this is just same kind of thing again with volcanic surface flows. We've got sills and intrusions also showing up. We've got sedimentary basins. There's lots of interesting stuff. Don't know, on this trip we won't have time to go to Dinosaur State Park, but Dinosaur State Park is an interesting, it's a trackway, and so you've got Mesozoic age sediments, silt and stuff that dinosaurs walked through, left their footprints, and the silt got lithified, and now we have sedimentary rock layers that have these dinosaur tracks in them.